Hey folks, so what is this continuous delivery thing anyway? And who am I to tell you? So let's talk about that first. So I'm a former recovering sysadmin. I spent about 15 plus years as a sysadmin. I think that was enough time. And following that became a professional services engineer at Puppet. Spent about 2 years in that role. I'm now the product owner for continuous delivery. That actually extends from a larger role that I've had at Puppet as methodologies lead, where I'm responsible for basically going around the company, looking at things that our professional services team do, and figuring out ways to standardize on those things. And as we did this and started to look at different things that we could standardize on, one of the most important ones we discovered is almost every single one of our customers is at some phase deploying some form of continuous integration, continuous delivery, trying to get to continuous deployment. And so as we started working on these things, Puppet started realizing we probably could do something with a product around that. And so I've been working for about 3 months now on continuous delivery at Puppet. So let's talk about what continuous delivery is. And fundamentally, continuous delivery comes down to cycle time. I will explain what that means. So code is value. And fundamentally, what we mean by code is value is this. You have a thing. You want the customer to have the thing. How long does it take from the thing to get from your head to the customer's hands, right? So a classic example of this is you've pushed out an application, you've pushed out a new version of Google Chrome, there is a serious SSL bug in it, you know what the fix is, it is a one-liner. How long is it going to take for your architects to realize that, get that translated into code, verify that the new code works in all the situations that it's supposed to work in, and then basically get this out to your customers? There's a great quote from Mary and Tom Poppendieck as part of their book, Implementing Lean Software Development, and it's, how long would it take your organization to deploy a change that requires just one single line of code, and can you do this on a repeatable, reliable basis? So as the principles behind continuous delivery were fleshed out, much of the work was done by Jez Humble at ThoughtWorks, and a good deal of this slide owes much to his thinking. Jez basically took the first principle of the Agile Manifesto, and I know a bunch of you will have varying opinions on Agile. Let's take it as read for now that Agile itself is okay, but that various Agile implementations may or may not be hurtful. But the first principle of the Agile methodology is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And so Jez basically took the words continuous delivery and said, well, let's make this about that. What is this? So let's lay a little bit of a conceptual foundation. And we need to kind of understand the underlying stuff behind continuous delivery. And this does mean delving a little bit into some theory and foundations. So we're going to get a little theoretical, but bear with me, because once you get this stuff, the CD story starts to make a whole lot of sense. So there's really two fundamental works to understand if you want to understand systems theory as it relates to continuous development or continuous delivery. One is the goal, which introduced the concept of theory of constraints. The other is the Phoenix Project, which came out recently by Gene Kim, who is talking at this conference. You should definitely go listen to Gene. And he introduced the three ways. And just to explain what these two things are, the theory of constraints, the goal is a book, talked about the notion of a factory, right? And we looked at American factories in the early 1980s. They weren't able to keep up with Japanese manufacturing lines. Why? Every single station in the factory was optimizing for local performance, right? So everybody was saying, if you've got downtime, you are bad. And we still do this in industry, right? We still point at a worker that's spending some time idle and say, you're reading Facebook. You are a bad employee. You should get back and do some work. Here, have another 100,000 emails. And we optimize for the performance of each individual person, when in fact that doesn't help us at all. So I'll give you for example. Let's say that you've got a factory, right? And the fundamental goal of the factory is to take raw inventory in one side of the factory, right? And pump out finished goods at the other end of the factory, right? That is the fundamental goal of the whole thing. Everything else is just a means to an end, right? We need to get stuff through that factory, and the quicker we can get stuff through that factory, the more that we're able to actually deliver to our customers on time. What theory of constraints pointed out is that if you've got a bottleneck anywhere in that system, if anything is slowing down the process, then improvements to anything else outside of that bottleneck in the system are actually illusory improvements. In other words, let's say that I've got a machine right here, and this is the slowest machine in my entire process, and I've got another machine right before it in the deployment process. And this machine is really slow, but I do a whole bunch to speed up this machine. What happens? You get a giant stack of ready inventory that starts to build up in front of the slow machine, right, while the slow machine slowly chews through it. This may remind you of something that happens with code released by developers and then sitting in front of ops to get released for quarters and quarters, or it may not. If it doesn't remind you of that, You should probably read the Phoenix Project, which basically takes the theory of constraint stuff and applies it directly to an IT environment and extends it a bit further philosophically. The factory metaphor is kind of important, and it'll continue to play in here. So Gene Kim talks about what he refers to as the 3 ways. And essentially these are 3 different aspects or 3 different stages that you go through as a company to get to a point where you can deploy software in this way. And the first way that he talks about, and I actually noticed, it's kind of funny, I noticed about 3 days ago that these align perfectly with our collaborate, automate, ship messaging for PuppetConf. This is totally tacked on there, but it totally makes sense. So first way is essentially automation, right? And what this means is just increasing the speed of your flow. So if you think about your business as being represented by your developers in the sense that your business has new features it wants to release, and your developers are the ones that actually turn those things into code to hand over to operations. And you think of the customer as represented by ops in the sense that once ops has their hands on it, gets their arms around it, and gets it deployed, it becomes a thing, right? So you've essentially got the business handing off things to the customer using developers and operations as proxies. So the first way basically says that you should do as much as possible to get the speed that things move from dev to ops faster. Nothing else, right? We're not worried about feedback right now. We're not worried about business process improvement. All this is automation. If you are in this room, you are doing this already. If you've ever used Puppet, you are doing this already. Even if you've just written a bunch of shell scripts to automate things, you are doing this already. But lots of companies aren't. Right? We all know that there are sysadmins that are sitting out there, and let's face it, we have plenty of jobs ourselves that are like this, where there's just the stupid thing where you have to hit the stupid button every stupid day, right? It's just there. And so what the first way basically says is the more you can automate those things away, right? The more you can get rid of those things, the better off you are. But it really says more than that. If we look at a developer handing things to operations as the same as the business giving things to a customer, this introduces a few rules that we can think about, right? Never pass a defect downstream. This is kind of obvious when you first start to think about it, but it starts to gain implications when you look at it in terms of the factory metaphor. As a business, you would never give a broken product to your customer, right? This is just something you wouldn't do. If it was known broken, you wouldn't let it out the door. And yet, in a factory, right, it's quite common for a component that is broken, when something gets put in at this end of the system, right, if it's got a fundamentally broken component, it may actually make it all the way through the factory process until it reaches the end and hits QA, and somebody realizes that the finished product is broken. But in fact, we could have known that the finished product was broken all the way back here, right? So all the stations that product moved through after it was broken were complete wasted time on the part of the organization, right? This was a total waste of time for everybody, and there's an opportunity cost. On top of the wasted time, there are all the working widgets that we didn't push through that. This applies equally well to IT operations and development, right? Development should never be passing known defects back to operations, and we'll talk about how to work on that in a little bit. Never allow local optimization to create global degradation. This is really what I was talking about when I talked about working on maximizing local stuff at the expense of the flow of the system. In other words, if I've got 2 people sitting here and here, and this one is slow and this one is fast, it is not worth my time to beat on the head of the fast one because he's not fully utilized. We want to make sure that the slow one is actually the one that's responding, but making sure that the person who's fast, who has their time completely occupied, is just simply a waste of our time. So we're always looking to increase flow. We're not looking to increase individual productivity. We're looking to increase overall flow through the system. And so we're always seeking to understand a profound understanding of how that system operates and how things move through it. But we're still thinking about the system, which means we're nowhere close to continuous delivery. We're starting to get to a point where things happen quickly, and we can do them repeatedly, and that means that we can measure them, which is all really good. And this gets us closer, but we're not there yet. The second way adds an important step. It adds a feedback loop, right? And again, most of us are doing this to some degree or another, although I would argue that it is more broken in IT than it is in industry. Right? From the concept of industry, most companies know that your customers should have feedback. This is why we have feedback forms. This is why we have salespeople calling up customers to find out what the heck is going on. And yet, in IT operations, very rarely do we actually have operations part of pre-planning, let alone post-mortems, right? All of this is sort of a problem. Again, that's something that hopefully many people in this room are doing already, but it is clearly a next step for a lot of people. And the feedback loops give you a bunch of things, right? So these are some hallmarks of a company that are practicing sort of second way methodologies. First and foremost, you're fostering information sharing across your teams, right? Largely, I tend to view that in terms of metrics, but also in terms of wikis, ticket tracking systems, right? Get on a single system, right? Share the information and make sure that everybody around your organization can see the same stuff. I won't spend too long on that because that's your generic DevOps message that hopefully we're like hammering you over the head with for the few days that you're here. But it's important, and it's important in the context of getting to this continuous delivery point. If people at various points of the system don't understand how other parts of the system work, how can they participate in optimizing its performance? Right? If I don't know this is your bottleneck, and I don't know that the way to control your bottleneck is by asking this worker to work slower, then I certainly can't possibly do anything to overall improve the speed of my system. All I can do is optimize for some subset of those components, right? So once I've got this information sharing and I've got this feedback loop, we're also now getting to a better understanding of our customers, right? Because operations is actually where the rubber meets the road. They're actually encountering the customer problems, and they are the customers of development in a whole bunch of ways. So now we're starting to get to a point where development can actually have feedback and better understanding of what it is that the customers want and what their pain points are. Obviously, we're going to fix defects faster because now we no longer have the situation of development tossing things over the wall, right? We've got operations that is now giving them feedback and saying there was a regression in this function. So at the very least, maybe development can work that into their release workflow somewhat earlier, right? And another hallmark would be adapt processes to other teams, right? You want to make sure that your processes are actually coordinated in such a way that all of your teams can work together. And this results in a decrease in delivery time and a decrease in unplanned work. So if we do all these things, and again, I would argue that probably most of us are, and I don't want to belabor this too long because it's common DevOps-y things, we actually have a continuous delivery mechanism at this point. If all of these things are in place, we're ready to do continuous delivery, right? So we are automated, we're monitoring, right? We're sharing details about this information back to the company and back to developers in a reliable way. And as a result, we have a system that's ready to push code through. That's like a car without gas, right? So ultimately, we need to build a thing, and now in order to do continuous delivery, we need to actually use it. And that leads us to the third way, which is continual experimentation and learning. Once we get there, we get to a culture of experimentation where we basically say, okay, since our feedback loops are so short, since it takes such a short period of time to get code from point A to point B, we can actually start to reduce smaller chunks of code that do more interesting things, right? So this actually makes it possible for a company to actually do the whole lean thing. How many people actually know in this room about lean startup and what the sort of lean theory is? Okay, so the basic fundamental idea for the people that don't is that you have a hypothesis, you want to test whether or not the market is willing to support that hypothesis, and you want to build as little as possible to get accurate feedback about whether or not that hypothesis is accurate before you go and build more things based on it, right? This fundamentally allows you to do that because you can now get a small amount of code, get it out there in the market, and actually see whether or not the code responds quickly, get that feedback back to your developers quickly, and push another iteration through. In a non-continuous delivery, in a waterfall type workflow, right, where you've got 18, 24-month release cycles, this isn't possible. Your company's going to spend 18 to 24 months working on a thing. If it is the wrong thing, you just lost 18 to 24 months of developer time, you lost 18 to 24 months of training time, and there's an opportunity cost, right? So you're allowed to experiment because experiments are smaller and releases are quicker. You also get to a point where you have an acceptance of risk and a learning from failure. One of the kind of interesting things when you look at systemic reliability is you look at an organization like the US military, which is really good at this, at defense in depth, right? Making sure that systems don't fall over. And one of the things that they assume is that every component in that system is going to fail, right? At some point or another, the people on the ground are tired, hungry, in bad circumstances, possibly shot, possibly dying, right? And they still need to be able to function as a unit and get done the things that they need to do. So how do you do this? You drill, and you drill, and you drill until it is muscle memory, right? In order to get better at hard things, and for folks that don't know about deliberate practice, there's a lot of writing on it. There's a great book, So Good They Can't Ignore You, which is totally worth checking out. Cal Newport's writings are worth checking out. He talks about deliberate practice, and the fact is the only way to get better at something hard, you can't just sit there and wish. You have to work on it. So in ops teams, you should be doing disaster drills. You should be deliberately injecting faults into your system, right? Because since you have such quick feedback in your system, it's really quick to fix the faults, right? So we should deliberately be introducing coding errors because we're doing this under our own control. We can actually determine when these things are happening and control when we're receiving feedback on them, rather than having a massive failure, which we then have to scope and figure out at the end of the process. And so as a result of this, we can test business hypotheses through pipeline results. And maybe most importantly, we will frequently add system stress to decrease cycle time, right? So in other words, One of the reasons that factories tend to fall over is everything is fine until that one huge order comes in, right? And then all the systems get overstressed and new bottlenecks pop up, and who knew where these things come from? Well, the answer is your system shouldn't be operating at 100% capacity all the time, right? If your system's at 100, and we say this as ops people all the time, if your system's at 100% capacity, it's overtaxed, right? We want things at 60% capacity. The thing is still true for humans. You need to have excess capacity in your humans in order to get code through, right? Otherwise, when the big code fix comes through, they're so busy with their giant stack of materials that they're working on that they can't actually take the time to address the problem. So we need to make sure that we are routinely adding system stress, putting huge loads through, putting big releases through that maybe don't actually do that much, but just make a bunch of changes, just to see how well our system actually handles getting these things from one place to another. And the cultural lesson in this is that pain is okay. Pain is inevitable, right? Experiencing pain in small bites more frequently makes us really good at it. And so this prepares us for a high level of redundancy because we're ready for everything to fail. So now, if you've done these things, your organization can do lean and agile, and everything is magical, and everything is great and wonderful, except how do we actually do that, right? So now that we've got the theory, let's bring that back to the cycle discussion, right? We've got cycle times. We want to reduce them. Where do we look? And it's pretty obvious if we look at the traditional waterfall release process. I mean, we all know what's going wrong here, right? We've all lived this nightmare. You've basically got a huge amount of planning that goes into this giant monolithic plan, after which what people will euphemistically refer to as an MVP gets reduced, which is not an MVP because it took 18 months of planning, all of which was wrong, but you find that out later, right? And then that's where all the budgeted time goes, right? And then the code gets dumped over into QA, test, and production, and the project plan has 2.5 weeks, right, for that process to happen. And then when we hit QA, we find all the bugs, and I mean all the bugs. And so never ends up in delivery, right? Ops ends up just iterating over and over again with development trying to fix each bug, and you're playing whack-a-mole with the bugs, right? You fix one and another one pops up. And ultimately, the second part of the process ends up mushrooming to be 6 times the size of the first part of the process, which is never in the plan. And so what happens as a result of that? Ops gets blamed for not properly planning for deployments. Or we get outsourced and they say, well, I'm giving all my business to Heroku because they can scale up on their own without us having to dump a ton of notice on them. Although actually you probably do need to dump a ton of notice if you're gonna put that much stuff on Heroku. But this is non-functional, right? And I'll give you a nice anecdote about how that gets to. I couldn't help put a Windows slide up there and say this is what failure looks like, but it's not about Windows. Everybody remember the Vista start menu, right? Shutting down or rebooting in Vista took about 4 or 5 mouse clicks to do. And so I remember, I think it was Joel Spolsky wrote a blog post that was like, why does it take me 5 mouse clicks to reboot in Vista? Like, who the heck designed this? And the guy that was actually responsible for designing the start menu answered with a blog post called The Windows Shutdown Crapfest. And I highly recommend you Google it. It's a great article, and it actually talks about how this happens. And what really happened was, it would take 1 to 3 months for a build of software to make it from one end of Microsoft to the other. You had the API team on one end of Microsoft designing the Power API. You had the GUI team on the other side of Microsoft designing, right, and the Power API, by the way, is responsible for tablets, smartphones, laptops, servers, right? In the meantime, you've got the GUI folks. They're worried about desktops at this point, right? Going back to Vista, they're worried about desktops. They're not worried about other systems. So one would design one and one would do their other code, and then like 6 months later, the code would meet, right? And none of it lines up, and so they're like, oh, we've got to make these fixes. And so they both have a big delta, and they push the deltas back into the system, and then 6 months later, they meet and go, hey, they don't line up again, right? And so finally, at the end of the process, they had to finally just call a big meeting, and you remember Vista took like 5 years to push out? This is why. So at the end of the process, they had a big meeting, and so they had a whole bunch of VPs, and nobody could agree on anything. And this is your classic example of software designed by a committee, right? We've all seen this, right? So how do we get from that to success? How do we get to a company like PayPal that pushes out tens or dozens or hundreds of changes in a day or a week, right, without having a problem? The short version of it is that you should read this book. If you haven't read Jez Humble's Continuous Delivery book, you should leave my talk and go read it. It's better than my talk. It's where all the ideas come from. But since you're all not leaving, I'll keep going. Essentially, there are some key principles that you can boil continuous delivery down to. Number 1, frequent automated releases, right? We are going to release frequently because it is painful and difficult, so we're going to do it a lot. Every check-in from one of your developers or from one of your ops people into your configuration management code is a potential release, because we never do work and say, I'll take care of this later. Right? How many of you have come across the comment that says, fixed me in the script that breaks everything at 3 in the morning on the day of production. No, we're not doing that. Every check-in is a potential release. Everything that you put in that code could end up in front of a customer. Furthermore, every change triggers feedback, and this is super important. One of the biggest reasons that things end up being so problematic, again, if you take a look at that Windows team, they were totally functional. They were working really, really hard, right? Each side was totally maximized. But the problem is they didn't get feedback for 6 months about whether or not their code was okay. That's too long. And during that 6-month period, you can't just wait for the UI team to finish and make sure that their tests run. You assume that everything worked according to spec, right? And you build a bunch more things on top of that. So when you find out it's all broken in 6 months, you're not just undoing the one change. You're undoing hundreds or thousands or tens of thousands of lines of code. And this is where you end up in that really gnarly situation where you have all this knotted up code that you now have regressions and like, why is everything broken? This should have been a simple change. This is true for everybody. Software is complex. It's hard. It's not easy. Nobody can hold it in their head. The more complex it gets, the worse it gets, right? And the only way to handle that is quick feedback. You need to know almost immediately when you commit the code, within 3 to 5 minutes, you need to know whether it has passed at least the unit test phase. And we'll talk about what that is in a second. But you need to make sure that it's at least passed some simple sanity checks, right? And ideally, within an hour or two, you should know if that code plays well with the rest of your code and is ready to move on to the rest of your systems. After that, things can slow down a little bit. You want to automate almost everything. If for no other reason, forget about speed for a second, it's repeatability. There are things that humans are good at and things they're not good at. And doing the same thing over and over again is proven to be something that we are really, really bad at. We vary, we get tired, right? There are all these studies that show that airport monitors, people that actually stand in airports and watch the people, you know, they stand there where you're not supposed to go back in, and they're supposed to watch you, and if you turn around, they yell at you. Except that they find that they miss like 1 in 5 people. And you're like, how can somebody who's sitting there all day, just looking to see if somebody is walking this way, can miss 1 in 5? They're awake, right? But the answer is, they're doing the same thing all day, every day. They're bad at it. Automate it, right? Automate it. Use a tripwire. Automate it, right? Build quality in. This is perhaps as important, right? So you don't have QA at the end so that this machine makes it all the way, right? We talked about the broken part earlier, making it through the factory floor and getting to the end and having wasted all that opportunity cost on all those machines. No, you actually do quality checking at each step of the way. So if there's a QA station after here, we catch really, really, really early that the code was broken, right? Or that the tool was broken. We pull that thing out and we don't waste that opportunity cost. We spend time on the things that we know are working. If we can get this guy fixed, we put him back in the process. That's fine, right? But in the meantime, build quality in. Make sure that quality is being checked at every step of your process. So since I'm stealing everything from Jez, I shamelessly stole his illustration of a deployment pipeline because I tried for about 2 hours to draw a better one and I couldn't. But one of the things that Jez likes to talk about is he talks about the deployment pipeline as sort of like a video game, where every release is trying to make it through like a whole bunch of processes and is getting slain by evil process monsters. And the goal is for the main character of the video game, which is your release, to make it all the way to the release stage, right? And you essentially see a diagram of that here, right? So we first have a check-in. It got past the version control phase. That was great. It hit the build and unit test phase. Failed. Boom, right back, right? And we have progressive releases that make it further and further through these phases, right, until we actually hit one that manages to get released. And there's a lot of detail about what unit tests are and automated acceptance tests are. Your organization can, I highly recommend that you do some reading on continuous integration to understand those things, but fundamentally, key point, unit tests are very short, should be able to run locally and go quickly, right? And then you have integration and acceptance tests that may take a very long time, but that test everyone's code together and actually make sure that they fit the business function. So, now that we've got an idea of what a delivery pipeline looks like, right? How do we actually take that drawing and turn it into a thing you can use? The easiest way to build a CD pipeline is to actually divide it into components in your head. There's a part of it that's continuous integration tooling, and that sounds very vague, but there's actually a good set of established continuous integration tooling that Puppet plugs well into to make this possible, and we'll talk about that in a second. Configuration management, obviously, that is why you are here. Application deployment is also probably why you are here, except that we don't talk about it properly, and this is one of the things that I'm hoping to change. And then monitoring and metrics. As far as your CI tooling, there's a ton of front ends you can use. This is an example, a real example actually, of us using Jenkins to test the CD pipeline that we've built. And if you folks head to the Circ room later, there's actually a demo of this CD process that's going where you'll actually see this happening. Jenkins is perfectly fine. This is Jenkins with the build pipeline tool, which is totally like wonky and odd, and maybe not the best thing for your production CI environment, but it's an example that works really well. But whatever your CI tooling of choice is, if you're a Bamboo user, if you're a Maven user, if you're a Hudson user, don't let this be a religious war, right? Use whatever tool your development systems are using. Don't fight it. These people have been doing this for a really long time. You should listen to them. They might be wrong, but you should listen to them. They've got reasons for doing things the way that they do. And if you understand the system, you can work with them. But whichever one it is, make sure your changes are getting checked into a CI server so that every time you check in some Puppet code, right, that stuff is actually getting at least unit tested, right? You probably want to run like, Puppet parser, validate, Puppet lint. Then you want to have some RSpec tests that might take even longer. And then, actually, in this demo that you see downstairs, we actually go and spin up a bunch of Vagrant VMs, deploy the code on it, and run smoke tests on the output. So we actually check to make sure that this website that you've changed actually comes up. And so we demo, and actually you'll see some of the screenshots of this. But we actually demo making the change and seeing it break, and then seeing where we find the break, fixing it, and watching the build go through. It is super important, if there's just one thing that you remember about version control from this talk, everything gets checked into trunk. Please, everything gets checked into trunk. Again, if you see Jez's talk, he might actually jump up and down and yell comically at you about this. He will say, you are not doing continuous integration if you are not checking into trunk. And I know for a lot of people in this room that is probably heresy. Generally, because operations is about 10 years behind development and thinking about these things, I say as a proud ops guy. So we're still like, feature branches, right? Yeah, no, right? What is a feature branch? You're not integrating. Continuous integration means you continuously, right, multiple times a day, integrate, which means check all of your code along with everyone else's code. If you are working in a branch, you are not integrating. You are checking your code against your code. And the point at which you merge your feature branch back into trunk, guess what? You've just recreated that giant monolithic waterfall merge window, right, that you really hated and tried to get rid of in the first place. You just made it on your laptop. Don't do that. It's fine to have feature branches on your laptop if you're like messing around with a feature, right, for a day. But like, if you still have feature branches left at the end of a day of coding, if you haven't merged them back into trunk and killed them, something's wrong, right? Certainly 2 days. Your branches should not live longer than that. And at core, you shouldn't have any branches. Trunk is fine. So we'll take a look here at some screenshots from a tool that Carl Kaum put together for us at Puppet, which basically integrates Puppet with VCS. So here we have an example, and you'll have to forgive me, the contrast on these is not great. But we've created some basic Puppet environments. So we've got a dev environment, a staging environment, and a production environment. And we've created a workflow that basically says, hey, code's going to move from dev to staging and production. You have the ability to define your own environments. You also have the ability to create what we call ephemeral environments, so something like my laptop, right? If I see something break in dev, I might want to pull it out of the pipeline and check it out on my laptop and get my laptop to stand up an identical environment for me, right? That would be an ephemeral environment. It's not part of the workflow. I just stood it up because I want to check stuff out. So you clearly want the ability to do this. We then created a Puppet face called PuppetConfig. So if you do a PuppetConfig list, you can see right here the list of latest changes into VCS. You see production, staging, and dev all at the same version, right? So now we go and make a change. So here I've made a change in my Hira data, right? And the key part of this is here. We have this PuppetConfig package. So what we're actually doing, what PuppetConfig package does, is check this code into version control, but not just my Puppet code, also my Hira code, right? Anything that is feeding into Puppet gets changed into this. And so now, when I go and do PuppetConfig list, I can see staging and production are still on my last prepared release. Dev is actually a release ahead, right? And now I go back and run my tool again and see what happens. And in fact, that's what this is a screenshot of. The change that I made in Hira broke my acceptance tests, right? It changed the directory that WordPress was in, ran my acceptance tests, my page didn't come up, boom, failure, we've caught it. We now caught an error before it went into production, right? And you can, this actually runs in under 3 minutes on a server. It runs in like 7 on my laptop, but still, in under 7 minutes, I just caught a major change that otherwise I would have seen happen in production because my code was syntactically fine. It passed Puppet parser validate, it passed all my smoke tests. The fact that I changed the reference of something to home WordPress from opt WordPress only manifested itself live. And one of the neat things that we discovered when we were trying to build the tools for this, actually, no, I'll come back to that, I'm sorry. It is relevant, but I will come back to it. Another thing we need to talk about very quickly is application deployment. We tend to conflate at Puppet when we talk about application deployment, we tend to conflate middleware deployment and configuration management with app deployment. You can deploy easy apps through Puppet, middleware apps, right? SendMail, Postfix, Apache, Nginx, Tomcat, those are all really good at being managed with Puppet. Web apps, not so much, right? Because you've got a whole bunch of dependencies. But that's what mcollective is for. And so I highly suggest that you delve deeper into the Puppet Enterprise toolbox and start looking at some of the, the actual orchestration tools that are built into it. That's where you might want to handle some of your dependency management, triggering staggered Puppet runs across different hosts at different times, making things spin up. Don't reach outside the Puppet toolset. First, look inside of it and look for opportunities to integrate. We have not done a great enough job of making it clear to people how well mcollective plays with Puppet, and I think you're going to see that as a theme over the next year. And now this actually gets to what I was going to say before, which is monitoring and metrics. You are not doing it right if you are not completely open, right? Everybody should be sharing data, and the easiest way to be open is not to tell people what you think they need to know, it's to actually show them, right? To actually give them access to all the monitoring metrics logs. Please, guys, don't hoard logs on your production servers and then make your developers ask for login access and then be like, no, you can't have login access, but I can zip up some logs. Would you like me to run an awk query for you? Like, how much time do you burn in an engineer's time doing that? How much time does dev burn? They couldn't get work done overnight because the ops guy that was working with them went home. Set up Logstash, right? Or Splunk, and send all your logs someplace if you don't want your developers logging on production machines, but let them look at the logs. Let them iterate on their own. Let them go back and forth with QA on their own. You don't need to be the bottleneck. Get out of the way. Let them speed up those systems, right? And then if you let them speed up those systems, you have a right to expect a lot more on your side, which we'll talk about. But one key part of monitoring is actually delving into the results of your Puppet runs. So this is Puppet Event Inspector, which if you were at the keynote this morning, you saw Joe Wagner, who's somewhere in this room, I think, basically demo. And it was kind of interesting because when we were setting up the CD demo, we were hoping to front-end it with Event Inspector, and it actually led us to root cause of a problem like in half the time that it was taking us with Dashboard. And the reason is it's sort of event-focused. So we were able to see that, in fact, with this opt-to-home WordPress, couldn't figure out why it was failing the platform tests. Turned out opt-WordPress was hard-coded in one of our tests. So in fact, the test was broken, right? So being able to find this stuff and expose it, one of the great things about exposing your data and your metrics is that you can slice them all sorts of unexpected ways. And when you slice your data in unexpected ways, you find things. You uncover things that you weren't aware of because you're looking at things differently. So now that we've basically talked about some of the tools that you can use to build this, the next question is, how do you get your company to buy into it? And the answer to that is, target the internal customer needs of the people who want the things. Most often, it's the business who actually wants the stuff. And although I'm talking about selling it to your business, the business is actually the easiest way to sell this, right? Because your business already wants to innovate faster. They already want to respond to market demands. They really want to fix your screw-ups really quickly because they just get mad at IT. They screwed something up in a spec. We implemented it, but now it's your screw-up and you own it and you need to fix it, right? So they want to do this, but also more likely one of your managers read on an airplane somewhere the lean startup and has decided, we must do lean, we must do agile. And they have hired bad consultants to teach them how to do it wrong. And now they're asking you to do it. So if they want that, essentially your answer to them is, I can do that and here are the things I need to do. And you need to start stepping through the processes that we've talked about of implementing these 3 different ways and some of these tools in order to make that happen. Your developers are probably the next most likely group to want continuous delivery because they're probably more aware of it. They've just been hanging around circles that have been talking about it for longer. And they've got really good reasons for wanting this, right? We yell at them all the time. Actually, how many people in here are ops? I probably should have asked this earlier. Yes, how many people in here identify more strongly with development? Okay, so the big war, right? The thing that we all fight over is that ops people are like, the crap you gave me didn't deploy, and the dev person was like, it worked on my laptop, and then there is hatred and anger and blood. But you know there's a reason they say that, right? And the reason that they say that is you didn't give them an environment that looked like production, and they couldn't test on it, and they had to get stuff done, and they had requirements and deliverables, and you took 5 months to deploy a VM for them and to make sure their code was checked out, and they went screw it. And if you're lucky, they spun it up in EC2. On CentOS or something, and if you're not, it's on like Mac OS 10, and now you're deploying it to CentOS 5, and you're screwed. But they can't test against prod unless their environment looks like prod, right? So we've got to be able to quickly spin up environments for them that look like our production environments, and that means tracking your data that's going through Puppet, your Hyra data, right? All of this stuff using the same manifests and the same tooling to deploy to development and to production, right? The same tooling all the way along the route. so that when basically your developers are releasing code, they are actually installing it in dev, your QA people are installing it in QA, using exactly the same code that deploys it in production. That is the only way to be 100% sure, or at least as close to being sure as you can, that things are going to work. Also, finding root cause is really hard, and merge windows are really hard. The smaller we make chunks of release, the easier it is for developers to find what root cause is, the easier it is for them to work their way through a merge window, because a merge window is very small and comprises maybe an hour or two worth of work, not a month or two worth of work, and so their lives become better. And finally, they need test and QA feedback quickly. The big bulk of the development time is not in the planning time, or at least it shouldn't be. It should be in the iteration process of trying to get your tests to pass, especially if you're doing test-driven development, right? And that means that you're going to need QA test feedback quickly, and that means you need to deploy to a real environment, not asking ops to stand this up in QA, waiting 3 weeks, then getting the server, then ops deployed it wrong, so they have to get it redeployed again. Then you say, but you dev, you didn't update the wiki. And they go, oh, you're right, it's in the different wiki that we stood up last week, right? And you fight back and forth about this. This is not going to enable them to develop things the way you want. This is how you force your developers to do all the stuff that you hate. We're equally responsible for it. They need that feedback quickly. And if you're ops, there are clear reasons for wanting this. Number one, you want the real handoff from dev. Give me an RPM. If I ask you to give me an RPM, I have to give you an environment in which RPMs can be installed with Puppet, right? If I don't do that, then you building an RPM is not helpful to you, or telling that the RPM doesn't install is not helpful to you. We want infrastructure changes tested along with apps. If the operations team is going to change the way a load balancer works, then the development team should be making changes to their code to accommodate that, or we should be alerted beforehand that that infrastructure change is going to blow up the app. Test your infrastructure code. We want small changes that don't prod on deploy day, right? We do not want 2 a.m. deployments. We want 30-second deployments, right? And that means making smaller deployments that don't do very much, that are easier to revert, right? We ensure changes are thoroughly tested. That's something we've all been arguing for. Dev wants it too. We just haven't made it possible. And the most common reason that ops want it is self-service. People are just asking them for VMs and servers all the time, and somebody's manually sitting there clicking buttons or running scripts to make it happen. Automate that stuff. Self-service is the root of all the technologies behind CD. If you can enable self-service, you are a good long way towards having platform setup that's going to support CD. The most important thing to understand, and I'll finish here, is that this is a culture shift. Tooling is important, but the reason I spent so much time talking about philosophy, and the reason I spent so much time talking about culture, is that people and culture are more important. And most critically from all this is the understanding that everybody owns the pipeline. Okay? It is owned by everyone. It is not dev's problem. It is not QA's problem. It is not ops's problem. You are a team. You are IT. You are trying to release things. And if you want your company not to go to Heroku, not to go to EC2, not to go off and throw their stuff into another system, you've got to make sure that your team owns the pipeline. If the build is broken, it's everybody's problem. If the build goes red, ops, dev, and QA need to get involved to fix it. It cannot be a siloed effort. If it's a siloed effort, forget this. This is all like smoke and mirrors. It's not going to happen unless everybody accepts ownership for this. So I guess what I would say is that if you're going to do this, the first thing you need to do, number one, talk about this with your team. Start talking about 3 ways kind of stuff. Start talking about how you can share information. If there's nothing else you can do, open up your own metrics. Just show people the metrics that you have available and make it easy for them to spin up their own. And the second thing I would say is start to pull down some of these tools and mess with them. Look at the things that you would ultimately need to build a CD pipeline, pull them down, start working with Puppet Enterprise and integrating Puppet Enterprise with them, and just see, hey, how easy is it to spin up some Vagrant boxes? How easy is it for me to spin up some EC2 boxes with this? Okay, can I get my Puppet code out to them? Okay, if I spin up a new environment, can I get that Puppet code to look different? Get those things working. Those are things you can do on your, well, maybe not on the conference Wi-Fi, but things you can do on your laptop when you get out of the hotel. And you should do them, because ultimately it's going to make us all more effective. So thank you. There's almost no time that I've left now for questions, I don't think. There's time for a few. So there's a microphone that nobody can get to. So if you can get to it easily, great. If not, I'll just repeat your question. So yeah, go ahead.
So do you think any of this is possible if the management doesn't adopt ownership of change?
Yes. So the question was, do I think any of this is... Yeah, if this is, is this possible if your management doesn't accept shared ownership of change? Yes, it is. Number one, because your management doesn't have to accept it, the people do, right? And there's lots of successful situations of cross-functional stuff being set up in between teams without management necessarily having to agree. Management doesn't have to agree that you get along with people. They just have to agree if you're breaking process, right? But if you're not making process, talking to people, sharing things with people, giving them access to stuff that they should have a right to access, isn't something that violates management. But number two, do it on your own stuff. Start working on your own things. I mean, even if you can get your own daily workflow to a point where you can do it, the business benefits are so obvious that once you manage to get one project turned around, your management will eventually turn around and say to you, we need to do this. If you're lucky, they'll credit you. If you're not, and it's like most companies, they'll say, we had this great idea. All of our teams should share everything. It doesn't matter, right? What you care about is actually getting there. So the point is you've got to show them the business benefits. Metrics are the only way to get there. You actually have to show them what the customer value is. Partner with sales. That's the easiest way to do it, right? If your company sells stuff, partner with sales and get them to work with you on linking your metrics to their Salesforce metrics so you can actually show the uptick in sales when your product started releasing updates to this, within a day instead of within 30 days. And actually start to find metrics that prove what it is that you're talking about. Once you show those to the business people are not stupid. We treat them like they're dumb. They're not. They're just as metric and theory driven as we are. It's just they're also as sort of culture and myth driven as we are. So they're not likely to believe us. Show them that you care about the business metrics, they'll do something about it.
Thank you.
Do I have time for one more? One more question? Yes?
Metrics, so give us lots of examples. I really struggle with trying to find some metrics.
Metrics, so like things you should monitor? Yep. Entirely depends on the app, and it entirely depends on what your business model is. So the question was, what should we measure? There's a saying, if it moves, measure it. I would agree with that. You may not know what you need to measure. Your app team, if you're an ops person, might, or your ops team, if you're an app person, might, right? So the key thing is, give your dev team the ability to build their own metrics, if possible, right? At the very least, let them ask you for metrics and give them a really reasonable SLA. I worked with Tom in Advanced, and he'll attest, this was the first thing that I did when I started working there, right? Was just like, look, if you've got something you want to monitor, let me know about it. If you can, please build into your application a status page that gives me internal status in a way that I can't understand. So if your app has a whole bunch of interlocking connections in it, get the app team to go ahead and write a status page that maybe returns back some JSON, right? That tells me like, yeah, this took 35 seconds, this took X amount of time, these are in these conditions, maybe assign a number to those things, curl them back and use those as metrics and graph those. You will find stuff, and you will actually find the things that are useful. All right, I think that's all we've got time for. Thank you, everybody.